Number 13 then from the 2013 Paper 1 Higher Maths. What we've got is a domain. There's a rational function here, form of a fraction. It said what values of x can't be in the domain. The domain means the numbers that you put into it. Well, you could put anything you like in and get an answer, as long as you don't end up dividing by 0 or having the square root of a negative. Well, there's no square roots here, so it means I can put anything in as long as I don't have the denominator coming to 0. So that's what I'm looking for. Are there any values of x that will make this denominator equal to 0? We'll just factorise that and find out. It must be x times x. I'm looking for factors of 12 that add to make 7. So that's going to be a 3 and a 4. This says the bigger of them must be negative. So the negative is going to go to the 4. And that says they're the same anyway. So x minus 3, x minus 4, which means x equals 3 or x equals 4. If x is either of them, I'll have a divide by 0, and so they can't be in the domain. So that would be answer A. Number 14. Scalar product of vectors here. The magnitude of A is 3, the magnitude of B is 2, and the scalar product of A and B is 5. So what does this come to? What's the scalar product of A and the sum of A and B? Well, split it apart. It's A dot A plus it's A dot B. Now it wouldn't matter what the length of B was if I didn't know the angle between them, so that 2 is not really any use to me. What I do know though is if I've got a vector with a scalar product with itself, it'll be all of its length times all of its length, since they're obviously parallel to each other, so all of the magnitudes will multiply. So A dot A is definitely 3 times 3. A dot B I wouldn't know if it weren't the fact they just told me. A dot B is 5. So I've got 9 plus 5, which is 14. Looking up 14, that's answer B. Number 15, a little trig equation this time, a tangent, and you know what tangent, which angle gives a tangent 1, that's 45 degrees. Where's it going to be? The tangent's negative. Tangent's negative here and here. So that means the angle's either going to be whatever angle gives a tangent of 1, which is 45 degrees, radians, thank you very much, so pi upon 4. It's either going to be pi upon 4 here, in which case x upon 2 will be pi minus that, and you can always write that as 4/4. Take away 1, so that'll be 3 pi upon 4, or it could be over here, in which case that's 2 pi, change it into fourths to make that subtraction easier, that's 8 pi upon 2, 8 pi upon 4, so 1 short of that would be 7 pi upon 4. So x is going to be doubling that, that'll half that denominator, 3 pi upon 2, or 7 pi upon 2. But x is to be less than 2 pi, so it's this one. 3 pi upon 2, which is C. So number 16 then, what have we got? An integration, an indefinite integral, and one with a function of a function in it. So we'll be doing the outside first, but significantly, of course, it's a function of a linear function, the only type that you can, in fact, integrate. So I'll be doing the outside first of all. It's a power. So add 1 to the power. Negative a half plus 1 goes up to a half. Divide by that half. Rather than writing over a half, I think I'd rather multiply by the reciprocal. That's 2 over 1, which is just 2. And then having a look inside at the linear function, its derivative is negative 6. You then divide by that negative 6. And don't forget the plus c, although it doesn't really matter here because we've all got plus c and nobody knows whether you've written it or not. So that's going to be negative 1/3, cancelling it down, of 1 minus 6x to the power of half plus c. Checking that in the solutions, we've got c for that.